Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is integration. It's still under techniques of integration, where we are going to learn the second techniques of finding integral of some special functions, and this technique is called integration by substitution. So let's begin. After completing the very lesson today, my dear student, will be able to find the integral of some special functions using this second technique, that is integration by substitution. This is what I hope you'll be able to do after completing the very lesson today. So my dear student, as usual in your favorite segment of the lesson today, also I'm happy to give you another interesting property of this very number 13. This number 13 has a lot of interesting properties. Today we are going to take another interesting property of this very number 13, and that will be done after completing my lesson today, so don't go away. To begin the lesson, my dear student, let's just consider some functions. Suppose you wanted to find the integral of 2x multiplied by root of 1 plus x squared dx. This is a very special case. Another special case, number 2, you wanted to find the integral of 3x squared multiplied by sine of, that is sine bracket 2 plus x cubed, then all this with respect to x. So this special case is the general formula for finding integral may not work here. That is integration by the formula alone may not work in these special cases. So to that we have to employ another technique, and it is this technique that you are going to see in this very lesson, that is integration by substitution. So another special technique must be used in this case in order to find the integral of these types of functions above. Before we see this very technique, let me just draw your attention to this very special cases. There are three things you have to take note in this case. That is, there are three things you have to watch carefully. If all of them happens, then you can apply this very method, because usually in a question they will not tell you this is the technique that you are going to use. It is either this by substitution or by parts. So it's you that will determine the appropriate technique that you are going to apply in order to find the integral. So let me just give you the three things that you have to watch carefully before you now jumped into conclusion that it is integration by substitution. So this is what you have to consider. Number one, it is product of two functions. That is, I can take 2x as one function, 2x as one function, and root of 1 plus x squared as another function. So you can see this as product of two functions. Then number two, you have to take note. The second function here can be a function of another function. And number three, you have to take note before you jump into conclusion that it is integration by substitution. What you have there in that function of function like this root of 1 plus x squared, the inner function which is 1 plus x squared, it is derivative of 1 plus x squared. If I ask you, you tell me it is 2x, you can see that is this very function that you have initially, which serves as product of this function and the function of another function. So if these three things are there, then you can now jump into conclusion that it is integration by substitution. Let me analyze the second one also. Looking at the second one, 3x squared can be one function times sine bracket 2 plus x cubed is another function. And looking at sine bracket 2 plus x cubed can be a function of function, because what is the bracket can be a function itself. So you now have sine of a function. So this sine bracket 2 plus x cubed is a function of another function. You can see these two things happen. It's product of two functions, and one of the function is a function of function. So the third thing you have to take note is that part that contains function of function. The inner function, it is derivative. If I ask you derivative of 2 plus x cubed, obviously you tell me it is 3x squared, and you can see 3x squared is the very first function that is multiplying that function of function. If these three things are there, my dear student, then you can now jump into conclusion that it is integration by substitution. And let us see the techniques So the technique says if you have the function y and that function y is such that can be expressed as a function of another function, that is f of g of x and times the g prime of x, that is g prime of x is one function and this f is another function, but this f is a function of function because you can see it's a function of g, and this g is what you have outside is it is derivative. So what you now do, you now let that in a function that is g of x to be your u. We are not substituting in a particular formula. We are trying to resolve this into less complex type. So if you let the inner one to be your u, then you now find the derivative of this function u, which will now have du dx to be equals to g prime of x. If that is the case, you now cross multiply. You now cross multiply to make du subject there. So you now have du equals to g prime of x multiplied by dx, that is dx times g prime of x. So if that is the case, you can now go back to this very function, the original one, and reduce it to a less complex type. So here du is nothing but g prime of x dx. So if that is the case, suppose you wanted to find the integral of this very function, f into g of x, then times the g prime of x dx. So you can see here g of x, which we let here to be u, and g prime of x times the dx, which we have here as our du. So this can be reduced to less complex one to be equals to integral of f of u du. I have replaced the g of x, look at it here, by u, because we said u equals to g of x. And I have replaced the g prime of x times the dx here by du. So this now reduced to simple function, which I wanted to find the integral with respect to u. So this is how you now reduce this complex function into simpler one. And when you now find the integral with respect to u, in the last result, you now take your u back. We are going to take examples how we can make use of this little manipulation and find the integral of these types of functions. So let's just move. Example number one, we asked to find the integral of 2x multiplied by the root of 1 plus x squared dx. So solution to this very problem, what we now do, we now copy down the given text, that is integral of 2x multiplied by plus root of 1 plus x squared dx. So let me just rearrange this 2x, let it come last. So I'm going to have integral of root first. That is the part that I have as a function of function. So root of 1 plus x squared. Then times this very function 2x then dx. I'll continue. So looking at this very function, like I have said, this is product of two functions. If 2x is one function and root of 1 plus x squared as another function, and this root of 1 plus x squared can be rewritten as a function of another function, because this is simply 1 plus x squared in the bracket, and that bracket raised to the power of 1 over 2 because of the root. So it can be a function of another function, and that function of another function, the inner function, which is 1 plus x squared, its derivative is 2x, which gives you this very function. So that tells you that it is substitution that you are going to apply there, integration by substitution. And what I'm going to do next is to let what is in the root to be my u. So let that very function be my u, that is u equals to 1 plus x squared. Then I'll now find the du dx, that is derivative of the function u. So I'm going to have du dx to be equals to 2x. Derivative of x squared is 2x. Derivative of constant number 1 is 0. So there I can make my du subject, that is cross multiply. Cross multiply there gives you du equals to 2x dx. So you now go back to this very function, the very task that you asked to do. Instead, what is in the root, you now have your u, and instead 2x dx, look at it, you just have du there. So there I'm going to have integral of root of u du. What is in the root there? 1 plus x squared is now replaced by u because u equals to that. And this 2x dx, which we said is the same thing as du. So I'll replace the 2x dx by du. So what now reduce my work now to find the integral of this very function with respect to u. So let me just proceed. Square root of u is nothing but u raised to the power of 1 over 2. Remember that in indices. So there I'm finding integral of this term with respect to u. Remember, integral the power increased by 1. And after increasing the power, you divide by that power after increasing it. So integral of this u raised to the power of 1 over 2 with respect to u would now be equals to u raised to 3 over 2. 3 over 2 is 1 over 2 plus 1. After the power increased by 1 gives you 3 over 2. And we are dividing by that 3 over 2, which we now change to multiplication by the reciprocal of 3 over 2, which gives us this 2 over 3. Then plus the constant of the integration. So this is the integral of u raised to half with respect to u. So what you now do is to take your u back. U initially we said is the same thing as 1 plus x squared. So I'm now replaced u by 1 plus x squared in this. So that I have my result in terms of x. So I continue. So this will now be equals to 2 over 3 into 1 plus the x squared. I have replaced this u by 1 plus x squared. Then that bracket raised to the power of 3 over 2 because initially u is raised to the power of 3 over 2, then plus the constant of the integration. And this is now the integral of this very function. Let's just take one more example. Example number 2, we asked to find the integral of 3x squared times sine bracket 2 plus x2 cubed dx. Solution to this very problem, copying down the given task, that is the given function, asked to find its integral. And looking at this function also critically, I can see 3x squared can be one function times another function, which is sine of this very bracket. And the sign of the bracket itself can be a function of another function because the bracket itself, what is in the bracket itself can be a function. So I have sign of another function. So this sign is a sign of function. And what I will now check again, this inner function, that is 2 plus x to cube, it is derivative. If I ask you, you tell me it's 3x squared, and it's exactly what you have here, the very first function that is multiplying that function of function. So that gives you confidence that yes, it is integration by substitution that we are going to employ here so that you now find the integral. So if I continue, rewrite this so that this 3x squared comes last, I'm going to have integral of sine bracket 2 plus x to cubed, then times 3x squared dx. So I will continue. So I'll now let what is in the bracket, that part that contains function of function. Then the inner function will now be your u. So I'll now let it to be u, that is 2 plus x to cube. Let me let it to be u. Then I'll now find the derivative of this function u, which will now give me 3x squared. 3x squared, this will now be the derivative of the function u. Then I'll now make du here subject by cross multiply. That gives me du equals to 3x squared dx. Then I go back to this, my initial task. There I said we are just reducing, we are not using a particular formula, but we are reducing this somehow. We are reducing this to a much less complex type. So there substituting, I'm now going to have, instead of this bracket, I'm going to have u. So it is now going to be sine u. Then instead of 3x squared dx, 3x squared dx, that 3x squared dx, which I have here, is nothing but du. So I'm going to have this now reduces to sine u du. So my work now reduces to finding the integral of this function sine u with respect to u. So let me move. Integral of sine, which we said is minus cos. So my integral of sine u is now going to be minus cos u, then plus the constant of the integration. So what remains is to now substitute your u back with with 2 plus x cubed. So there I continue. So I'm going to have minus cos inside the bracket is 2 plus x cubed, then plus the constant of the integration. And this is the integral of this very function. So my dear student, this is the end of this very lesson. I hope with the few examples given, you'll be able to find the integral of some special functions using the techniques called the integration by substitution. So let me just move to the last segment. Maths is fun, and explain what is interesting again about the number 13. So 13 is the smallest prime number, which can be expressed as sum of two distinct prime squares. That is, this 13 is prime and can be expressed as sum of two square numbers, and those numbers would now be prime numbers. So let's just see how we can express this number 13. 13 is the smallest. Of course, there are other prime numbers that can be expressed as sum of two prime square of the prime numbers, but 13 among them is the smallest, which means all other prime numbers before 13 cannot be expressed as sum of squares of the two prime numbers. Let's say the two prime numbers that are both squares, that is square of the prime numbers. So I have my 13 can be expressed as 2 raised to 2. 2 is a prime number, and the 2 raised to 2 means the square of 2. 3 raised to 2 means square of 3, and the 3 is another prime number. And if I now find the 2 square, it gives me 4. 3 square gives me 9. If I add 4 and 9, it will give me my 13 back. So 13 is the smallest prime number that can be expressed as a square of two other distinct prime numbers. Thank you for your attention. We'll see more of interesting things about 13 in my next lesson.